This is a chair that we found in the real world that has an exponential function in it. The side of the monkey bars show an exponential function. The legs of this table show an exponential function. The support of this chair makes the shape of an exponential function. The flipped projector makes the shape of the exponential function. The back and seat of this couch make the shape of an exponential function. Okay, this is our exponential function. Our exponential function is our pair function. This is what the graph looks like for our exponential function. Our formula for our exponential function is y is equal to 2 raised to the x. You can put any number for the coefficient and it will give you a graph similar to this. Right here, close to 0, our graph never touches 0 because the exponential functions always come close to 0 but never touches 0. And then it increases rapidly because it's an exponential function. The domain for our exponential function is negative infinity to positive infinity. The range for our exponential function is 0 to infinity. This is our original function. This is our transformed function also. You can see right here is our original function, and right here is our transformed function. Our formula for our transformed function is up here. Y is equal to 2 raised to the x plus 2, and then back down to 2. You go up 2 because of this 2 right here. It moves it up 2 spaces. And the reason it moves to the left is because of this x plus 2. Whenever you have an x plus 2, when the x and 2 are combined basically, it moves to the right or left. Since it's a positive, quadratics say it moves to the left, so it moves over 2 spaces. The domain for this function, domain, is equal to negative infinity to positive infinity. And the range for this function is 2 to positive infinity. This is our reflection for our apparent function of our exponential function. You can see the original function was right here, and we basically reflect it over the y-axis right here. So we flipped it, and now this is what the new reflection looks like right here. And our formula for our new reflection is equal to y is equal to 2 raised to the negative x. This is our parent function flipped over the x-axis. Right here you can see our original function would look like this, but it's flipped over the x-axis. Our equation is y is equal to negative 2 raised to the x. This is our exponential function that has been shrinked by 1/2. And our equation is y is equal to 2 raised to the negative 2x. That's the formula that makes this graph look like it is. This is our parent function that has been stretched by 2. Our equation is y is equal to 2 raised to the 1/2 x. And this is what you get when you stretch our parent function horizontally by 2. This is our graph for our exponential function that has been vertically shrink and stretched. You can see that the equation has both vertically shrink and stretch in it, so it's a combination of both. And this is what the graph looks like when you vertically shrink and stretch it.
For the exponential function, I will be covering line of symmetry, even or odd, and end behavior. Line of symmetry for an exponential function, it does not have a line of symmetry because 1/2 is not a reflection of the other. Even or odd, exponential functions are both even and odd. It just depends on the exponent if it will be the same or the opposite. The end behavior is where the graph is at its end. So as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches 0, because the line actually never goes below the y-axis. It never actually touches the y-axis, actually. So it just approaches 0, not actually hitting it.
I will be teaching you about zeros and one-to-one correspondence of an exponential function. An exponential function has no zeros because it does not cross the x-axis. It gets really close, but it will never touch it. An exponential function also, it has one-to-one correspondence with logarithmic functions, such as this right here. And that's it.